Hi, I'm Eddie Shore. Welcome everybody. I do have three demo 12Cs that are passed around. There is a 12C Platinum that has three demonstration programs: quadratic equations, logistic curve fitting, and greatest common divisor. And then there was one regular classic 12C that has decimal to binary conversions. Feel free to play with them. So that is my topic. I'm talking about one of the flagship calculators that Hewlett-Packard came out with back in 1982, which is the Hewlett-Packard 12C. Actually, one of them I'm passing out was a clone, a Victor, which is a clone of the 12C Platinum. So, learning how to do this. Okay.
F5.
F5, thank you. Okay.
The button on the side.
Buttons on the side. Okay. So the purpose of my talk today is to expand the 12C beyond the basic financial capabilities that the 12C is well known for, which it does so well. And I'm including mathematical tricks for the 12C, and then some applications that you can do with the 12C. Working with several assumptions here on the presentation that I have here, and then the documents on the drive. I did everything using the classic 12C, which is 99 steps. Obviously, they work as well on the Platinum edition, which has 400 programming steps. The major difference is on the classic, you only have 2-digit step markers. The Platinum has 3-digit step markers. Also, the code for last X, because they moved the last X from the gold shift from the enter on the classic 12C to the plus key on the Platinum. So you got, instead of 4336 and 4340. I'm not using any trigonometry on this because there's no trig built-in functions. And I'm assuming that for the most part we're working with fixed 2 mode, rounding everything to 2 digits, because on a financial calculator we usually do that. If you haven't had a chance already, Valentin Abil, I'm sorry if I mispronounced your name. He has 2 great articles. One is describing the polynomial solver for the 12C and the trig functions. I do encourage you to check that out if you haven't. So we're going to go to mathematical tips here. The first is arithmetic, and basically an alternative way to multiply by 100 is pressing enter, 1, swap, and then take advantage of the percentage total function rather than enter 100 times. It doesn't save steps per se, but it might save a little bit of speed. The next one, divided by 100. Traditionally, you could use enter 100 divide, but instead you could use enter 1 and then the percentage key, and it saves 2 keystrokes. And when you're working with the HP-12 Classic, you only have 99 steps, so space does come at a premium. So this might be a not only a time saver, but also a space saver as well. There's also the absolute value, which is basically we're just squaring the number and then taking the square root. So there's no square function, but you can do 2 power and then square root, and that comes into play when you do a sine function. Just for those who don't know, the sine function is it will return -1 for any negative number, 0 for 0, and +1 for any positive number. And the algorithm is enter 2 power, square root, and then divide. Essentially what you're doing is copying the number to the y stack level, taking the absolute value of what's on the x level, and then just dividing it. One of my favorite functions is the modulus function. And a way to take a modulus function of two positive numbers, say A mod B, is this little algorithm here. So A, enter B divided by, and then you're going to take it then as the last x function, swap, do the fractional function, and then multiply. And here's one that will come into play a little bit later, is like you could take the number of digits of an integer, which essentially is you're taking the common logarithm, but we don't have a common logarithm on the 12C, so I had to use the natural logarithm, and taking the natural logarithm, then dividing by the natural logarithm of 10, taking the integer, and then we add 1. So for example, if we had 200 has 3 digits, so, but the common logarithm of 200 is 2 point something. So we're ignoring the decimals at this case, in this case, and we're just worried about the integer part, and then we're going to add 1. So the algorithm of this is natural logarithm, and then EEX1 to quickly type in 10. Natural logarithm again, divided by the integer, and then 1, and then adding the 1. Everything that I'm doing in this presentation assumes that you are in RPN mode. We don't have pi on the 12C. We can input the full 10 digits of pi because the 12C allows only up to 10 digits. But each digit counts as a step. So what you can do instead is use approximations, and you can kind of get away with it because most of the time we are using fix 2 or maybe fix 4 or using less decimals in the display. So I decided to favor the 355 divided by the 113, and this gives a pi accurate to 5 decimal places. Obviously, it costs you, and if you're using much complicated and complex calculations, but if you're using short calculations, this is a nice approach. And this only takes 8 steps. And in reviewing the presentation, Richard Nelson suggested that you can do this mnemonic by taking the first 3 odd digits twice. So 1, 1, 3, 3, 5, 5. Divide the last 3 by the first 3. And other options would be 22 over 7, square root of 10. So there's some other options to save some time and space.
This has very good approximation. Very good.
Yeah, it's usually good
For the simplicity.
Yes. So for this example here, the surface area and volume of the sphere, so for step 6 to 12 is where I enter the approximation of pi. And then I go through the calculation, and then I display the surface area, and then I calculate the volume. As you'll notice in a lot of my examples, I end my calculations with a go-to 0, 0. If you're using the platinum, it's going to be go-to 0, 0, 0, and that's basically telling the 12C stop executing the program steps. The way I like to approach the number of inputs on my RPN programs is if you have 2, go ahead and enter them on the stack, and then the program can take care of the storage and manipulation. Anything above 2, for example 3 or more, I usually have the user pre-store everything into the registers first, because if you have 3 and you're just putting it on a stack, you're going to use a lot of program steps saying, okay, store this, roll down, store this, roll down, store this again, roll down, and then start your calculations. So by using having the user pre-store everything in advance, you're going to save some space. And I think it's a little bit, and it allows for a little bit more customization because you don't have to, if you have different scenarios, you can change one variable or 2 variables or however you need and then run your program. Here, you can use the test x is equal to 0 to determine choices. So what you do is you're going to set aside one register, and it doesn't matter which register you use. It works for any of them. And you're going to set that as like a flag variable. So, for example, if I had choices A, B, and C within my program, I'm going to assign choice A to the flag value 0, B to flag value 1, C to flag value 2, and so on. Now with the classic 12C, depending on the length of your calculations, you could fit to 2 to 4 choices. Obviously with the Platinum you can go further than that. So it's basically, at the beginning of the program, I recall the test registration, take the test value. If it's 0, then I can go straight to the x equals 0 test. If not, I can put 1 or 2 or whatever number, subtract, then I invoke the x equal to 0. And if that is true, go to the appropriate line number. So in this example here, I have 4 conversions, United States to international. So like 0, I have 0. I have 1 conversion, and then I have another conversion. So I have pounds to kilograms, inches to centimeters, miles to kilometers, and it depends on whatever your choice value is. It will take you to the appropriate section. So for this particular program, I have the value to be converted and the choice. So if I wanted to convert to, so that is the program here. So for example, if I wanted to convert from inches to centimeters, I would put the choice value at 1, and then at the beginning you do all your comparison tests, and then I use the go-to line to point me to the correct spot where I need to go. And that way you can offer the user several choices. And then this is the end of the program here. And then at the end of each section, I put a go-to 0, 0. So I stop execution so I don't bleed into the next section. Take advantage of statistic values if you have statistical calculations. So if you're using anything about the mean, the n, and the sums, like the sum of the x value, sum of the y value, sum of the products, you can use those. But then that will leave you with registers 7, 8, 9, and 0 for other calculations. If you do use statistics on the 12C in your programs, what I recommend is to not include the clear statistics registers inside of the program, because you don't want to accidentally clear stuff before you do any calculations. You have the user clear everything outside before program evaluation. Also, what's become one of my favorite features of calculators is the linear regression. So if you notice that in the manual, the 12C, and then other calculator books as well, they use the linear regression to show you how to do exponential regression, simulate power regression, simulate logarithmic regression. Here I use the linear regression here to simulate a simplistic logistic curve fitting. Using the curve y equals 1 over the quantity a plus b times e to the negative x, and I use the transformation x e to the negative x and then 1 over y. As long as you can get your original equation into some type of linear equation format, ax plus b, or actually Hewlett-Packard has mx plus b, m being the slope and being the intercept, you'll be able to fit a variety of curves. So in a program like this, I have this program into two parts. The first part is manipulating x and y as needed, and then storing the point using the sigma plus. Unfortunately for the 12C, there's no way to easily retrieve slope and intercept, but they do have a small algorithm that you use in the that is in the manual. So in the second part, whenever you're ready to calculate the parameters, the slope and the intercept, that's where you start. You go to the appropriate line number. In this case, line 8. I go for the intercept first and then the slope. And then this y character, that's like the y prediction function, the y prediction common r. And that is how to take advantage of the linear regression to fit many curves. So the 12C does not have pure subroutines, but you can simulate them. Again, we're going to designate one variable to be your flag, and then we're going to use the x equals 0 test again. If you're going to use subroutines though, or try to simulate subroutines, it is very important to plan ahead and to know how many times a certain calculation is going to be used, because that will help you calculate what the flag needs to be. So if you're going to use the same calculation maybe 3 times, you're going to start with a flag variable of 2. And then each time the subroutine's used, that flag variable is going to get knocked down by 1. And then you will use that flag variable to determine where to point your program. So that is, you're going to designate a register for a flag variable, and then you're going to do your main portion on the top, and then that will be followed by your subroutines. And then at the end of your subroutine instructions, that's where you're going to start comparing your flag variable. I recommend if you do this, I recommend writing your program down and obviously listing the step numbers. That way you can keep track of where everything is supposed to be.
Did you formulate a guideline of what using twice versus 3 times versus 4 times? And maybe if your routine is short, you just might put the routine in there?
Or can you just assign a value, you can call it arbitrarily, and when it looks at the value in that flag, says, oh, it's like 1, I gotta go back here.
Yeah.
So it doesn't have to be, you don't have to count down, just, because you're gonna test where to go anyway.
I haven't found a way to implicit to do indirect branching, but
No, not indirect. It's this. You're pretty much is the same
Yes.
thing, except you don't have to count it down. You can because at the end of the routine, it has to know where to go.
Right.
Well, it's gonna. You can tell it in this code. I want you to go to this. So from the value, it says I'm gonna. You don't have to decrement. Just associate a value with a return location. With a
that would work too. Yeah,
with a
especially if you're going to do it just twice.
Yeah.
Amir, that can be a bit tough given the conditionals that are on the 12C.
Ah, okay.
It's x equals 0 and x less than or equal to y.
Ah, okay.
It's just that's Eddie's done a lot with a very hard program machine.
Okay. Yeah, the fact that it doesn't have subroutine, that's tough. Yeah.
It is very tough. Like if you were just going to do it twice, and you could save some space that way, it's like you can designate, say, 11 to the flag variable. Okay, 11 uses 2 steps. Let's say 9. 9 to, and then at the end, it's like test, is the thing 9? And if it is, go to step A. If not, go to step B.
Okay.
So I can see if you're doing it twice, you can do it that way. So this example here is the approximate derivative Not the best approximation formula for the derivative, as I found out, but it illustrates up the point of how to do the subroutines. And as you can see, you start with the flag, you set up the flag variable. I designated in this program register 3 to be the flag variable, and I assigned it 1 because I'm only going to call the function twice. And then the main program starts here, and then when I designated the subroutine where the subroutine starts, so go to 23 is where my subroutine starts, and then my first round, I go back here, and then here's my second round, and then at 23, that's where my subroutine. And that's kind of a way how to simulate subroutines. And then here's my subroutine calculation, and then I recall my test variable. Is it 0? Is it 1? Whatever, or whatever number it is. So in this case, like if I recall 3, is it 1? Is it 0? If it's 0, go ahead and go to 17 because we're in the second round. If not, I'm going to subtract 1 from a register 3, and then set up the display for future calculations, and then I'm going to go to point A. This is where planning and writing down or noting down the program and the main routine is really going to help, because you need to know where you want to point out. The program to, because we also don't have labels in the 12C. Of course, depending on what size, the classic 12C with the 99 steps, I would probably recommend no more than 2 or 3 times because of space. Obviously with Platinum, you have a lot more room to work with. So you have to be aware of the additional cost of testing the flag variable.
I don't remember, was each digit a step?
Yes.
I put in pi.
Mm-hmm.
If I don't need, 7 or 8 places of it, I shouldn't waste the space.
Right.
If you're using pi more than once, you might as well store it in the register outside the program and just recall that register, because you'll be saving quite a few steps.
Absolutely.
Yeah.
And if you do use pi, that's that is a yes, definitely. And then in
Because
fact,
I
you
used to
can
have-
store the whole thing if you wanted to.
I first owned the HP-55, and if you look at the application pack, often they make you do either preparatory stuff or after the fact you do, because they don't have enough memory.
Right. So here's some additional examples. Here's the standard quadratic equation. One of my favorite beginners examples. So solving ax squared plus bx plus c equals 0. And here I take the route of, I'm asking the user, please go ahead and store a, b, and c in registers 1, 2, and 3 respectively. And then I went ahead and calculated the discriminant and stored it in R0. And I display it because it's going to be pretty important. Because if it's positive or 0, the next 2 results are going to be real roots. If it's negative, then you've got complex conjugates, so the next 2 results will be the real part and the imaginary part respectively. And here's the rest of the program, and here's the complex root, and then the real root area. One of my other favorite applications is the greatest common divisor, and I've programmed it so no matter which order you enter the 2 integers, it will work. So at the beginning, you'll do a comparison to see which one's the max, which one's greater, which one's the lesser one. So R1 would have the maximum, R0 is the minimum, and then at that point I will start the Euclidean division routine and then calculate the remainders. The remainder 0, obviously go to the end if it is, if not, set up for the next loop, and then keep on going until you get the GCD. If you want to save space, obviously you could have the user do, okay, enter maximum, then minimum, or minimum and maximum in a certain order. Probably one of my favorite applications to do this, and this is probably one of the few times that I don't assume a fixed 2 mode, especially going the other way, is the binary to decimal conversion. So you store the binary integer, and in this program I don't assign a sign digit, so they're all positive numbers. So, and then I determine the number of digits, again, so like you're simulating taking the common log, right? So you've taken the natural logarithm of the integer and then divide that by the common log of 10, and then taking the integer amount and adding 1. And then it goes through the loop and it goes through the conversion process to decimal. And I think the maximum number is 512.
No, it's 1023.
1023, thank you. Now, if you're going to go the other way around, which is the other notes, you will need to set up your fix. You'll need to set up the fix to allow as many digits, fix 9 to allow as many digits as you can. And that's the way that you can. That's several of the ways of how to expand the 12C beyond the finance functions and take advantage of the math functions. Again, is there any more questions?
I guess the platinum with 400 steps.
Yeah.
It's
Helps a lot.
tempting to use that more, because then you can put some of your routines along with some other stuff.
Yes. Absolutely.
The original Platinum was supposed to have 700 steps. They were afraid teachers and universities would freak out. Too much stuff in it.
The Swiss Micro has a 12C also. And you can through USB download, upload, and download program. So that's the one that you got a way to store. And
Yes. Thank you, guys. Thank you, everybody.
Thank